Welcome to the next lesson in the Authentication and Authorization chapter. In this lesson, we will be implementing role-based access control for fine-grained authorization inside of our modular monolith. If you recall from our discussion about the users module in previous lessons, and if you don't, no worries, here is a reminder, the users module will be responsible for managing roles and permissions. These are the two components that we need to implement role-based access control. We will have the users assigned to specific roles, and each role will have a connected set of permissions. Overall, the user's permissions will be derived from any assigned roles, and then the respective permissions assigned to those roles. Of course, we are going to take the unique set of the available permissions, and then based on that, we can determine if the user has sufficient rights to access a particular resource, or if not, they're going to get a 403 forbidden response. I want to make a few remarks on role-based access control in ASP.NET Core. We are currently using Keycloak for authentication and user management purposes, and I mentioned that we are going to add roles and permissions into the users module. So we are going to fetch the necessary data for authorization from the users module, and then based on that, determine if the user should be given access to a particular endpoint. The reason for implementing it like this, instead of using Keycloak to also take care of authorization, is to have very fine-grained control into our authorization policies. This is what the overall authentication flow will look like once we add role-based access control. The user is going to authenticate with Keycloak and get an access token back the same as before. What changes this time is when we send an API request with an access token included, we are going to apply some claims transformation to the claims principal that is derived from the current access token. In this step, we are also going to include the user's permissions, and then after applying the claims transformation, we're going to authorize the user, and if the user has sufficient access, we're going to authorize them and give them back the API response. Because we have a lot of code to write for this lesson, I'm going to slowly introduce the classes that we will need to implement role-based access control, and you will be able to find all of the classes under this video as I introduce them into the source code, while I'm going to be commenting on the implementation and any design choices. We are going to start the implementation from the users module by adding support for managing roles and permissions. So these are the first two types that I'm going to add. The role class, which is just a simple class with an encapsulated constructor. It only has a name property, and I defined two instances of a role, an administrator role that is going to have elevated permissions, and then a regular user in our system represented with the member role. The roles will be assigned a set of permissions, and this is the permission type. It's equally simple, it only contains a code, and this is the set of permissions that I defined for implementing our authorization policies. So let's take one example, the get user permission, and the unique code for this permission is the resource that it refers to, so users, and then the name of the permission. So in this case, I have a get user permission, and the unique code is users read. I also have a users update permission, an events read permission, an events search permission, and you might be wondering what is the difference between these two. Well, if you recall, we have a get events endpoint, which we defined in the events module, and this endpoint returns all of the events in the database, and it's more appropriate for an administrator user to call. We also have the search events endpoint, which allows anyone to search through the list of published events, filtering by the category and the start and end date. And this is a more public-facing endpoint that we want to expose to the regular users of our system. So we will handle these permissions differently, and the search events permission will be assigned to a member, whereas the events read permission will be assigned to an administrator. There are many other permissions inside, and I'm not going to go through all of them. Just keep in mind that these permissions will be assigned to the respective roles, and then we are going to be adding these permissions as custom claims that we will use to implement authorization policies. The next thing we need is to connect our users and roles. The simple way is to just encapsulate a collection of roles within the user type. So let's say the user contains a list of roles. Let's give it a name of roles, and I'm going to assign a default value to this field. Inside of the create method, after I have created a user instance, I can say user roles, and note that I have access to this private field because I'm inside the user class. And what I want to do is to add a new role to the user, and I can access the static member role exposed on the role type. Our factory method is called from the register user use case, And after we create the user instance, we add it to the repository. Let's head over into the insert method, where I need to implement an additional step, and that is to loop through the roles of the user. I don't currently have a roles property, so let's go ahead and create it, and I'll explain why we are doing this. Let's say that this is a public property returning a read-only collection of roles, and let's return it by saying roles and then create a new copy of the internal list collection. If I go back to my user repository, I'm going to say user roles for each, and then for each of the roles, I'm just going to attach them to the database context. So I'll say context attach and pass in the role instance. And the reason I am doing this is because my roles will live in a dedicated table called roles. I'm also going to be seeding the roles when configuring EF Core migrations. So this is just a way to tell EF Core that the current role instance already exists in the database, and you don't need to go ahead and create a new record in the roles table. Just go ahead and insert the user into the database and add the user ID and the role ID in the respective join table. And this brings us to our next step, which is configuring the role and permission entities with EF Core and also seeding any initial data. I'm going to introduce two new classes inside of the users folder, and just a reminder that you can grab these types from under this video. Let's take a look at the role configuration type. It implements the INID configuration for the role class, and I'm configuring that this entity belongs to the roles table. I'm also using the name of the role as the primary key of this table and setting the max length, which is going to slightly improve performance. I'm also configuring a relationship between the roles and the users by saying has many user with many roles, which means that this is a many-to-many collection. And I'm configuring the join entity between these two tables. I want the table name to be user roles, and I'm configuring the role primary key in the join table to be called role name instead of the role's name value that EF Core is going to assign it by default. Lastly, I'm seeding the two roles that I have by calling hasData and specifying role member and role administrator. And when I create my EF Core migration, these two values will be inserted into the roles table. We also have the permission configuration type. It also implements INID type configuration for the permission entity. It's stored in the permissions table. The permission code is a primary key, and it also has a maximum length. Then I'm telling EF Core that it should seed all of the permissions that I have defined in my domain layer. And of course, we could manage all of this through writing SQL scripts. I'm just placing it in the code so that we can make it more explicit. The next step in this type is configuring the many-to-many table between roles and permissions. I'm calling it role permissions, and I'm seeding the initial data by using this helper method, which accepts a role instance, a permission instance, and returns an object that contains the primary keys of the two tables that I'm joining. So the role name is the primary key of the role entity, and then the permission code will be the primary key of the permission entity. And you can see I have separate segments for configuring the permissions that I will assign to the member role, and then a more detailed set of permissions that I will assign to the administrator role. We also need to tell our database context that we will be using these configurations. So let me copy this twice, and I'm going to add the role configuration as well as the permission configuration. And now it's time to create our database migration. We already have a database migration which takes care of creating the schema and the users table. And if I were to create a new migration, it would only include the roles and permissions. However, I'm going to delete the existing migration because it's easier for me to just recreate it and continue with this demonstration. And I suggest that you use the same approach because we are still in development. So I deleted the old migration, and I'm going to create the new one by saying add migration, create database, specifying the user's database context, and then the output folder for my migration file. I will set this to target the user's infrastructure project, and the startup project will be Evently API. Now, when I execute this command, we are going to get a new database migration, and you can see that we have the permissions table, the roles table, the users table, the join table between roles and permissions, the join table between users and roles, as well as the data that we are seeding for the permissions, the two roles that we have, and the data inside of the join table between roles and permissions. I'm just going to drop the user schema in the database. It's going to be recreated when I start my application, and I will register a new user that's going to have a role assigned to it, as well as any required permissions. With the user schema recreated in the background, we can take a look at what we have inside of our tables. So let's start with the roles table, and you can see the administrator and the member role. The permissions also has the values that we seeded in the entity configuration and that was applied using our database migration, and the role permissions table contains the required connections between the permissions and the roles. Inside of our users table, I created one user, and you can see that this user is assigned to the member role. I'm going to go ahead and assign this user into the administrator role as well, so that we can give this user elevated permissions and make it easier for testing in the future. Now that we have the roles and permissions as part of our database, it's time to implement the authorization component, and we're going to handle this in our common folder because authorization is another cross-cutting concern that we definitely want to share between our modules. I'm also going to be introducing the components for this implementation as required, and you can find all of the necessary source code under this video. So let me add two more files, the custom claims file, and it's going to contain two custom claims that I will be introducing to my claims principal. I will add a subclaim and a permission claim that's going to store the actual permissions assigned to the current user. Inside of the claims principal extensions, I have a few extension methods on the claims principal type, and these are just helper methods to get a concrete value from the claims principal. So in the getUserID method, I'm looking for the subclaim, and if this claim exists, I'm trying to parse it into the user identifier. This will be the identifier of the current user in the users module, but it's also going to be the identifier of the customer in the ticketing module and the identifier of the attendee in the attendance module. I have another helper method to get the identity ID, which will come from the name identifier claim when we access our API as an authenticated user, because ASP.NET Core is going to internally map the subclaim from the JSON Web Token into the name identifier claim in the claims principal. And then the last helper method that I have is to fetch the permissions from the claims principal for the current user, and this could contain more than one claim because the user could have more than one permission. But I'm making sure to convert this to a hash set so that this only contains unique values, and I'm making the lookup slightly faster because a hash set has a constant time access when specifying the actual value. This is all we need in the authentication folder. Now I'm going to introduce another folder called authorization, and I'm going to add a few types inside, which you can find under this video, and let's examine what I introduced to enable permission authorization. The first thing we need is to define an authorization requirement by implementing the respective iAuthorizations requirement interface. I'm calling this type a permission requirement. It's going to accept the permission value and assign it to a property. Then the next component that we need is going to be a permission authorization handler. This is an implementation of the authorization handler generic type, and you can see that we specify our permission requirement. And the implementation is incredibly simple. We're just going to access the claims principal on the authorization handler context and call our helper method to get a hash set of the permissions for the current user from the user's claims. Then we're going to check if the permissions contains the value on the permission requirement, which is the permission property. And if that is the case, we're going to succeed the authorization handler context by calling the succeed method. Otherwise, we can just return from this method, and this is going to cause a 403 forbidden response from the API. The next missing link is the permission authorization policy provider. This is an implementation of the default authorization policy provider, and what I'm doing here is injecting the authorization options, which is a required argument for this type, and you can see that we are passing it to the base constructor, and I'm overriding the method to get a policy. The policy name provided here is going to actually match the name of the permission that we have defined as the authorization requirement for a particular endpoint. And what we try to do in this method is to find an existing authorization policy for the provided policy